was excited. She had finally been prescribed a new oral medication to help with her chronic condition. She eagerly opened the bottle and took the first dose. But what she didn't know was that her journey with this pill would face many hidden obstacles. First, the medication was a delicate compound, and as it passed through the stomach, the pill's stability was tested. The acid in her stomach, with its low pH, began to break down the pill before it could even fully dissolve. In the process, some of the active ingredients were lost, and Annie didn't get the full benefit of the dose. Next, the pill had to face the challenge of solubility. The medication wasn't particularly water soluble, and as it mixed with the stomach acid, it had trouble dissolving properly. The less it dissolved, the less her body could absorb. Annie wondered why she felt only a little better, not as much as she had hoped. As the medication began its journey into the intestines, another hurdle appeared. Annie had taken the pill right after a large portion of French fries, fried chicken, and mac and cheese served for lunch. The fatty food in her stomach slowed down the gastric emptying time, meaning the pill took longer to leave the stomach and enter the intestines. This delay reduced the time the medication had to be absorbed, affecting how effectively it worked. To make matters even worse and complicated, Annie was also on other medications. One of her other pills interacted with the new one, altering the way it was absorbed. The concurrent medication affected the enzymes that normally processed her new drug, reducing its effectiveness even more. Finally, there was the form of medication. It was a tablet, hard to swallow at times, and not ideal for Annie's sensitive stomach. Sometimes the pill got stuck, irritating her esophagus, further delaying its action. The form of medication simply wasn't ideal for her body. Despite these challenges, Annie remained hopeful. Understanding these barriers of medication helped her discuss with her doctor about possible solutions, like adjusting the medication's form or timing, or even considering alternative therapies. It was also a reminder that even the best intentions in medicine could be hampered by the complexity of the human body. Welcome to Let's Simplify Pharmacology. In our last video, we covered the first phase of pharmacokinetics, absorption. We went over important terms related to absorption, looked at different routes of medication administration, and focused on the oral route. I also highlighted the key factors that influence oral medications absorption. Hello, I am Nurse Frenny, and I am the nurse educator here at Faba Nursing. In this episode, we will take a closer look at the various factors that act as barriers to medication absorption. We'll also explore how these factors impact the absorption of oral medications using Annie's story from our introduction as a real life example. Let's get started. Let's first consider stability and solubility of the medication. A drug's stability or the stability of drugs refers to the medication's ability to maintain its chemical, physical, microbiological, and therapeutic therapies over time. And the drug solubility refers to the ability of the drug to dissolve in a solvent, which is usually a liquid. It's therefore important to note that for a drug to be absorbed, it must first be in a solution form. especially at the site of absorption. And note that poor solubility can lead to inadequate absorption, while instability may cause the degradation of the active ingredient, reducing the medication's effectiveness and safety. Solubility is also a key in drugs bioavailability, which is the portion of the drug which enters the systemic circulation and can provide therapeutic effects. Stability ensures that the drug remains safe and effective throughout its shelf life. In Annie's story, we saw that the medication wasn't water soluble, which made it difficult to dissolve properly. As a result, her body absorbed less of the drug and she didn't feel as much improvement as she had hoped. Next, we're going to consider the GI pH, which is the gastrointestinal pH and the gastric emptying time. pH refers to the acidity or the alkalinity of a substance or environment. Gastric emptying time, however, refers to how long it takes for the medication to move from the stomach to the rest of the digestive system. It's important, however, to note that when a drug is taken orally, it must withstand the low pH of the stomach and the various gastrointestinal secretions, including enzymes that degrade the drug. This explains the reason why peptide drugs such as insulin cannot be taken orally, because they are highly susceptible to breakdown in the stomach. Most absorption occurs in the small intestine, so gastric emptying time is crucial. Foods, especially fatty foods, usually slows gastric emptying time or slows gastric emptying, thus delaying the drug's absorption. That's why medications often absorb more quickly on an empty stomach. In Annie's case, she took her medication after a large meal that was high in fat. This delayed the time it took for the pill to leave the stomach, slowing the absorption and affecting the medication's effectiveness. Other concurrent medications can affect medication absorption. When medications are taken together, they compete for the same transport proteins in the body, affecting the absorption and distribution patterns. This can alter the efficacy and safety of the medications. This brings us to polypharmacy, where multiple drugs are prescribed, often in older adults, which may cause interactions that affect drug action. These interactions can either increase or decrease the drug's effects or cause adverse reactions. As nurses, it is crucial to conduct medication reconciliation to ensure that the patients are taking only prescribed drugs, and be careful to educate them on the risk of taking multiple medications. We will dive deeper into drug interactions like the synergistic, additive, and antagonistic effects in a future video. Medications usually consist of an active ingredient, which is the drug, and an inactive ingredient, which is the additive. These additives help the drug dissolve and be absorbed. Different drug forms, such as tablets, capsules, and liquids, affect absorption rates. Capsules dissolve quickly, especially when filled with liquid. In contrast, enteric-coated tablets protect the drug from the stomach acid and dissolve in the small intestine. However, these coatings don't always dissolve as expected, especially in older adults, which can affect absorption. Controlled release formulations such as CR, which stands for controlled release, ER, extended release, and SR, sustained release the drug slowly over time. It's however important to verify the doctor's order, especially when similar drugs are available in a different release form. In any story, the form of medication contributed to the delayed absorption as the pill irritated her esophagus and took longer to dissolve. Thank you for joining me in today's episode. We explored the factors that act as barriers to absorption and how they impact the effectiveness of oral medications, using Annie's story to illustrate these concepts. I want to leave you with this motivational quote from President Theodore Roosevelt. Believe you can, and you're halfway there. You've got this. Don't forget to subscribe, like, share, and comment with your thoughts and questions. I'll see you in the next video. Thank you and take care.